Bismillahirrahmanirrahim. Rotational kinetic energy. When an object is rotating about an axis with an angular speed omega, then it has rotational kinetic energy. Each particle of the rotating body will have kinetic energy that is given by the formula half mv square. So, if any mass or any part of the mass of this body is rotating in a circular motion or rotating motion, then this mass has a kinetic energy half mivi square. Since the tangential velocity of every particle, where is the tangential velocity of this mass? That is in the direction of this red vector. So, the tangential velocity of the particle, every particle, depends on the distance r from the axis of rotation. We can substitute this tangential velocity by using the formula v is equal to r omega. In this formula, so by replacing the term v is equal to r omega in kinetic energy term, we get the new shape of the kinetic energy formula, that is half mi ri square omega square, where omega is the angular speed. The total rotational kinetic energy of the rigid body is the sum of the energies of all the particles. For example, rotational kinetic energy is equal to sum of kinetic energies of all the particles and is equal to half mi ri square omega square. So rotational kinetic energy can be written as by taking 1/2 common from this summation sign outside the bracket, and omega square or omega is the angular velocity which is common in all the particles masses, then omega is taking omega square common from the bracket. The remaining term inside the bracket will be the sum of moment of inertia of all the particles. And if it is given the name capital I, then total moment of inertia capital I, then total kinetic energy becomes half I omega square, where I is called the moment of inertia. There is an analogy between the kinetic energies associated with the linear motion, means half mv square, and the kinetic energies associated with the rotational motion. You can see that there is a common terms. For example, half is over here and half is over here. Similarly, mass is replaced with the moment of inertia and linear velocity is replaced with the angular velocity. We know that in circular motion, mass is replaced with the moment of inertia and linear velocity is replaced with the angular velocity. So there is an analogy between the kinetic energies of linear motion and kinetic energy in circular motion. Rotational kinetic energy is not a new type of the energy. The form is different because it is applied to the rotating object. As in rotating object, there is no linear velocity and there is only angular velocity. So we use the value of angular speed in the rotational kinetic energy formula and we use the moment of inertia value. Then we get the total kinetic energy or rotational kinetic energy of a rotating body. But the unit of the rotational kinetic energies are the same, which are joules. Now we see the rotational kinetic energy of disk and a hoop. If two bodies starts moving down from their higher positions, then during motion, their motion consists of rotational and translational motions. It means that they are rotating around itself, around their own axis, or they are spinning, and similarly they are moving in the forward direction. So there are two motions, rotational motion and translational motion. They are translating from one position to another position. So there are two motions, rotational motion and translational motion. And the energy associated with the motion is known as kinetic energy. So there are two types of motions. So there are two types of energies, kinetic energies. One is rotational kinetic energy and another is translational kinetic energy. For both bodies, disk and hoop, disk also has a rotational kinetic energy and translational kinetic energy. Similarly, hoop will also have a rotational kinetic energy and translational kinetic energy. What is the rotational kinetic energy of a disk? You see that rotational kinetic energy of any body, as we have proved in the previous slide, that rotational kinetic energy of any body can be calculated by the formula half I omega square. And we know that for the case of disk, total mass is separated or spread over the whole disk. It means that total mass of the disk, if we consider or we take the total mass is equal to m, then whole mass not have the radii s, or some mass is at 0 radius and some mass is at the maximum radius throughout the disk. So we will take the average of the moment of inertia. It means 0 plus mr square over 2, and 0 plus mr square over 2 is equal to half mr square. So moment of inertia of the disk is equal to half mr square. Putting the value of moment of inertia in this formula, for the rotational kinetic energy, we get half into half mr square into omega square, that is 1 over 4 mr square omega square. And we know that r omega is equal to v. It means r square omega square is equal to v square. So putting the value of r square omega square is equal to v square, we get the value half 1 over 4 mv square. So rotational kinetic energy of a disk and a hoop is continued. In case of hoop, the moment of inertia is actually mr square, as whole mass is at the end of the hoop, so total radius is involved. Now we have to take no average but total moment of inertia is mr square, not average of mr square, as whole mass is using the radius r. So moment of inertia will be mr square. The kinetic energy or the rotational kinetic energy is given by this formula, and by using the value of I, we get half mr square omega square, and r square omega square is equal to v square. So rotational kinetic energy is equal to half mv square. You see, in case of disk, rotational kinetic energy is less than the rotational kinetic energy in case of hoop. It is half of mv square, while rotational kinetic energy of disk is 1 over 4 of the mv square. It means that disk will move faster as it has less rotational kinetic energy and more translational kinetic energy, while hoop will rotate around itself more as it has more rotational kinetic energy and it will have less translational kinetic energy. So its speed of translation will be low, but speed of rotation will be high. While in case of disk, speed of translational will be high, but speed of rotation will be low, and it has low or less rotational kinetic energy of value 1 over 4 mv square. Thank you for watching the video, and please visit www.cancollege.com and subscribe this channel and press the bell icon for more information and more informative lecture videos on all subjects. Thank you.